Welcome everyone. Today we are going to review the basics of factoring. So the first thing you know about factoring is the GCF, which stands for the greatest common factor. So the greatest common factor is what you can divide every term in your expression by. So when I look at problem number 1, I'm looking for what can I divide both 2x and 8 by. So both of those can be divided by 2. So 2 is their greatest common factor. So we're going to factor that out of both of them, put it on the outside of parentheses, and then divide both of those by 2. So we'll get x minus 4. So we have just factored out the greatest common factor. Number 2, I look at both of these. I think the greatest common factor looks like it's 2 again. So I can divide them both by 2. So 2 goes on the outside. If I divide them both by 2, we get 6x squared plus 5. Second one, both of the terms have variables. So yes, both of those can be divided by 2, but since they both have an x, I also would divide them both by x. So 3x is going to go on the outside of parentheses. If you divide 3x squared by 3x, we have 1x left. And then 9x divided by 3x, the 3 is left and the x has been factored out. So we're left with 3x times x plus 3. The next two are trinomials, so they've got 3 terms. So we're looking for what can I divide all of these terms by. So all 3 terms have to be divisible by the same number. So I can divide all of those by 2. So 2 is their greatest common factor. So we're left with 9x squared minus 4x plus 1. So a common mistake I've seen is that 2 divided by 2, students think that's 0 and make it disappear. But 2 divided by 2 is 1, so make sure it stays there. Next one. Looking at these, all of them were divisible by 3. That's the biggest thing I can divide them all by. So 3 goes on the outside. Then I divide each term by 3. Finally, on the last one, each of these is divisible by 2. And all of them have an n. So the smallest n is a single n, so I'm going to divide it by a single n. So 2n is the greatest common factor. If I do 2n cubed divided by 2n, the 2 is gone. And we have 3 n's, we took away 1, so we're left with 2 n's left, or n squared. 20 divided by 2 is 10. We had n squared, we took away an n, so we're left with an n. Plus 8 divided by 2 is 4, and we factored out that n. Sometimes when doing greatest common factor, like on the homework, when you factor a number out, maybe you'll think it's the greatest common factor, but if you look at your answer and there's still something you could factor it out, you want to factor it out again and then multiply it by the number that's on the outside of the parentheses. All right, difference of squares. Difference of squares is fun because when you multiply them, something special should happen. So x times x is x squared, x times minus 6 is 6x, 6 times x is plus 6x, and 6 times negative 6 is minus 36. So hopefully you notice the special thing is the like terms cancel each other out because a negative 6 plus 6 is 0, so they are gone. So we are left with x squared minus 36. Same thing with the second one. We've got 25x squared minus 35x plus 35x minus 49. The middle 2 terms that are like, negative 35 plus 35 is 0, so they're gone. So we're left with 25x squared minus 49. So this happens when you have 2 binomials that have the same terms but different signs in the middle. So we have a plus and a minus, but the other 2 terms are the same. Same here, we've got 2 things that are the same, but the plus and the minus are different, and that causes that difference of squares. So hopefully for this pattern, we noticed the middle terms cancel out, or they equal 0. So to go backwards from this, because we're going to focus on factoring today, we are going to turn the difference of squares back into its factored form. So the way that I like to approach this is I think, like, what is the square root of the first term? Well, square root of a squared is a. So I'm going to have 2 sets of parentheses. So my first term is a in both of those. And the square root of the second term is b, so b is going to be my second term. And then one group gets the plus and one group gets the minus. It doesn't matter if you do minus or plus first. This only works if there's a minus sign in the middle. So if there's a plus sign, this process does not work, so this one is not factorable. So it only works when you have two perfect squares and there's a minus sign in the middle. So if you look at those examples, I see two perfect squares, so I can take the square root of both of those and a minus in the middle. So that means it is difference of squares. So I'm going to take square root of the first term, that's x. Square root of the second term is 4. So my two groups are going to start with an x and an x. Second term will be 4 and 4. One gets a plus, one gets a minus. And look at the next one. Same thing, perfect squares and a minus sign in the middle. So square root of 4x squared is 2x. Square root of 81 is 9. So when we set up our groups, they're both going to start with a 2x, and they're both going to end with a 9. And then one gets a plus, one gets a minus. Even if the variable comes second, it's the same idea as long as they're both perfect squares with a minus in the middle. So square root of 4 is 2. Square root of g squared is g. So we're left with 2 starting both of them, g ending both of them, a plus and a minus. Our last example, when I look at 12 and 27, those are not perfect squares. However, the first thing we should check when we factor is if there's a GCF. So can I divide both of these by something? Yes, they're both divisible by 3. So if I factor out a 3, we're left with 4x squared minus 9. Now I have two terms. They're both perfect squares, and there's a minus sign in the middle. So at this point, we can do difference of squares. So square root of 4x squared is 2x. Square root of 9 is 3. So that 3 is going to stay on the outside. And then in our two groups, the first one's going to, they're both going to start with 2x. They're both going to end with 3. And then we get a plus and a minus. All right, that is your crash course in the basics of factoring. So next class, we will look at factoring with trinomials.